Once again, welcome to another episode of Nuclear Chemistry. In this particular video, I will be talking about stability of the nucleus. Stability of the nucleus or stability of the nuclide. Now, I want to say this. This is how our periodic table looks like. Then we have something like this again. We have something like this. Then we have something like this. Then we have something like this. This is usually the S block. Here is the P, here is the D, and this is the F block. The F block, that's where most of our transition elements lies. Most of our radioactive element lies. Talking about the lanthanide and the actinide, the rare earth element and the artificial element. All the artificial elements we see, the uranium, the thorium, all those elements, they were created through a radioactive process. And most elements, they disintegrate. Like what I said in my previous video, one of the reasons for their disintegration or for their spontaneous breakdown is because they are not stable. So there's something we call the stability belt or band of stability. This is the neutron. Why? This is the proton. So a stability belt is a graph of a neutron versus the proton, whereby the vertical axis has the neutron, while the horizontal axis has the proton. So a question might come in this format: uranium 238 and here is 92. Is uranium stable or not stable? Or let me take it this way: is it radioactive or not? We already know that uranium is found at this part, so definitely uranium is an artificial element. That's to say uranium is a radioactive element. But how can we detect if this guy will be above the stability belt, will be below the stability belt, or will be on the line of stability? So for you to determine the stability belt of a particular element, you are going to use the neutron to proton ratio. So for any substance at all, for any element at all to be stable, the neutron must be equal to the proton. So for you to say this particular element is stable, the neutron number must be equal to the proton. If the neutron is greater than the proton, it will be above the stability belt. Let me do it this way: if neutron divided by proton is equals to 1, it will be on the stability belt. If neutron divided by proton is greater than 1, it will be above the stability belt. If neutron minus divided by proton is less than 1, it will be below the stability belt. So this is what you do: neutron minus proton is equals to 1. That means it is stable. If the neutron divided by proton is greater than 1, it will be above. Neutron divided by proton is less than 1, it will be below the stability belt. Let me say this again: for every element, or for a nuclide to be stable, I repeat, for a nuclide to be stable, the neutron minus proton is equals to 0. That's a condition. Number 2, the neutron divided by the proton is equals to 1. Then the last one, the neutron is equals to the proton. So if a question comes like this: if neutron minus proton is equals to 0, which of the following is correct? A is stable, B not stable. The answer is what? It is a stable nuclide. Then if you have something like this: neutron minus proton is equals to 1. If neutron divided by the proton and gave us 1, is it stable or not stable? The answer is what? Stable. If neutron number is equal to the proton number, is it stable or not? It's stable. Now let me just give you some examples so that you understand better. We already know that uranium is 238. Yes. Then we have 92. So our electron number, our neutron number will be 146. Just for you to subtract this from this, you give us 146. So if you have 146, that is our neutron number. Remember, the formula is neutron all over what? Proton. And our neutron number is 146. Then our proton number is 92. So let's push our calculator. 146 divided by what? 92. Our answer is equals to 1.58. Okay, let's just say 1.6. So since our answer is greater than, the first thing that should come to your mind with this answer is this value equals to 1, greater than 1, or less than 1. 1.6 is definitely greater than 1. So since our answer is greater than 1, then it will be above the stability what? Belt or band of stability. That is to say, this particular element is not stable. So there is a higher tendency that is going to disintegrate for it to form a stable nuclide. So when this guy disintegrates, let's assume that we have a thorium. Thorium we have 234, and here is 90. So if you have 234, let's say 234 minus 90 as per the neutron number, so you have 144. The formula is neutron all over proton. The neutron is 144 while the proton is 90. So if you divide it by 90, our answer is 1.6. So since our answer is 1.6, realize that thorium will also be above the what? The stability belt. Now let me give you something that will make us understand it clearer. Let's try with hydrogen. Hydrogen we have 1 1, hydrogen we have 2 1, and hydrogen we have what? 3 1. The neutron of this hydrogen is 2. 3 minus 1 here will give us 0, and here will give us 1. 2 minus 1, so it gives us 1. Then the neutron to proton ratio here will give us neutron is 2 divided by 1. Here will give us 0 divided by 1. Then here will give us 1 divided by 1. 2 divided by 1 will definitely give us 2. Here will give us 0. Then here will give us what? 1. That is to say, tritium is 2, will be above the stability belt. This is tritium. Protium is 0, will be below the stability belt. Proton is 0. Then hydrogen, this our deuterium, is 1. So deuterium will be on the stability belt. That is to say, deuterium is a stable nucleus compared to protium and then tritium. So let me quickly give you a particular question, then you try it out. Let's say boron here is 11, and let's say here is a boron, hydrogen, lithium, beryllium, boron. Boron is 5. So if you have something like this, is boron a stable nuclide? The nuclide of boron, is it stable or unstable? So please, from what I've explained so far, like what I said, for you to say the particular substance is stable, or for the nuclide to be stable, that is to say the neutron minus proton will be equals to 0. The neutron divided by proton is equals to 1. Neutron equals to proton. So that's for that. If the neutron divided by proton is now greater than 1, that means it is above the stability belt. If it is less than 1, it is below the stability belt. If the neutron number is greater than the proton number, it can never be stable. That means it is very, very much what? Radioactive. And like what I do say, radioactive elements will disintegrate. They are going to have a continuous disintegration, a continuous breakdown for them to form a stable what? Nuclide. Thanks for watching. Please drop this answer in the comment section. Hope to see you in the next episode. For now, goodbye.